The 7 bridges of Konigsberg. Konigsberg, unlike other cities, cannot be found on any modern maps. The city was between both sides of the Träger River. Prior to World War II, the city was in Germany, but now resides in Russia. Mathematician Carl Gottlieb Euler became obsessed with these bridges and could never find a solution to work them out. Leonhard Euler invented a new way of thinking known as graph theory, which is now used to solve modern math problems. Konigsberg is a mathematical problem originally solved by Leonhard Euler. The bridges soon evolved into a tradition to attempt to walk in and around the town that only meant crossing the bridge one time. It soon became evident that this was impossible. Mathematical modelling. What is it? The process of using various structures, graphs, equations, diagrams, scatter plots, tree diagrams, etc. These are often used to represent real-world problems in order to find realistic solutions. Why is this problem still unsolved to this day? Around 1736, mathematical expert Euler showed that although some have attempted, it is clearly impossible to complete this particular walk. How was this proven? A diagram known as a network was invented. This network was made up by a number of different vertices. A vertex is a point where 2 or more lines meet, and arcs are part of a curve, especially a part of the circumference of a circle. Euler referenced 4 individual vertices highlighting each riverbank and the islands. Each vertice has been marked as A, B, C, or D. Why is this problem known as impossible? If a network carries 2 or more odd vertices, it cannot have an Euler path, meaning it is not transversable or cannot pivot. Is it possible to design a walk that crosses each bridge in Konigsberg only once? The simple answer is no. It is quite impossible to design a walk that crosses each bridge in Konigsberg only once. However, if you do create another bridge separate to the other 7 individual bridges, it is somewhat possible. This bridge would be placed in between 6 and 7 bridges, directly across from 3, or between 2 and 4, directly across from 3 once again. If not, suggest where a bridge could be built to make this walk possible. Conclusion. To conclude, the evidence I have shown throughout this presentation demonstrates that it is merely impossible to cross over each individual bridge only once. Although some have tried, it is still not solved.